Hello everyone. So in this lecture, this will be the first lecture of your gas dynamics. So in this lecture, I will be discussing the complete syllabus for gas dynamics for GATE Aerospace. Okay, GATE Aerospace exam. So what are the important topics and syllabus which we will be following for this lecture series? Okay, I'll be covering all these important topics. So okay, so the I have mentioned these as a sequence. If you want, you can go through. So this is what I was following. Okay, so okay, this is fine. Yeah. So yeah, so this is what I'm having. So typically if you see your gas dynamics covers 7 to 9 marks for your gate exam. So this is important subjects. So this will be your forming your base for your jet propulsion. Okay, jet propulsion, again your rocket propulsion. So you must cover these subjects thoroughly. You must be knowing all each and every concept in gas dynamics, because this is the very important subjects, interesting subjects, I'll say. Many interesting phenomena happens because this is a high speed flow. Okay, so anyway, so if you see, this is what important topic I have mentioned, and I will be following all these topics for, and I'll try to make sure that it should not go beyond 20 lectures. Okay, and I will also try to keep it max to max 30 minutes one lecture, so you guys will not get bored. Okay, and productivity and the learning, the understanding of concepts should be better. Okay, so yeah, and one more important thing, that in this lecture, that this is only 20, I'll try to keep it as a 20 lecture, right? I'm saying that I'll not cover as a university exam or university subjects. Okay, so which is not required, because we are only, our focus is for gate exam, right? Our focus is for gate exam. So we'll not be focusing as a university syllabus. We'll be only focusing on the what are the important topic is required to score good marks in gate exam from the gas dynamic subjects. Okay, as of now. So I'll be not going for big derivation, because 100% derivations are not required. And derivation, what derivation is required, I'll tell you. And after doing derivation, or from derivation, what are the important uh, equations you are getting, that we must keep in mind. Okay, and I'll tell you what formula you need to block, or what equations or derivation you need to go through. Okay, so I'll make sure that you, at the end of the complete lecture, you'll be in a position to solve every numerical from gate exam or previous year. You'll be playing with the gas dynamic question in gate exam. So I'll make sure that you'll understand each and every concepts, and what the formulas are required, you must be having your notes, okay, on your formula sheet. Okay, so what are the derivations, what are the formulas required, I'll block those formula. I'll try to emphasize at that time that you must having this formula in your formula sheet. So these are the things. I hope it is clear, and it will help you to cover this gas dynamic subjects quickly and understand more and more in this. Okay, so I'll also suggest that that this is a very interesting subjects, so you must cover this for gate exam. Okay, so the first chapter I am having that fundamental concepts, will be dealing with this, and then isentropic flow. So all these important topics which I have mentioned. Okay, so compressibility, speed of sound, continuity equation, momentum equation, energy equation, these three equations I'll be giving you, and I'll be also saying that these two equations are very important for solving numericals and answering many theory questions. So beautifully, you need not to worry about this, that these equations are, we'll be dealing with integral form of continuity equation, or momentum form of sorry, differential form of continuity equation. No, that we are not going to do. We will be directly saying the simplified form of continuity equations, and how we can apply for normal shock wave and moving normal shock wave and oblique shock waves, all those. Okay, and many more. And then isentropic flow, which is very important and basic for your all the subjects, all the topics upcoming. Isentropic relations. Then what are the stagnation properties, P naught, T naught, or rho naught? Okay. Then velocity or sound area velocity relation. Again, this is very important for nozzle or duct or diffuser. Again, CD duct, flow through CD duct, area Mach number relation, maximum for flow mass flow rate, characteristic Mach number. Okay, all these things we will be beautifully seeing this, and what is the significance, or all this we will be seeing. You need not to worry about this. Then we have next chapter, we are having normal shock wave. So normal shock wave, again, two types of, in this two segregates are there, that standing normal shock wave and moving normal shock wave. So I'm again saying that I'll try to wrap up this gas dynamics in 20 lecture itself. I'll not go more than that. I'll try to do that. Okay. Then we have normal shock wave. So okay, just to give you some idea or flavor, that okay, yeah, normal shock wave is, okay, so your normal shock wave is like this. Okay, Normal shockwave, this shockwave is like this is very thin shockwave. Okay, and it will be perpendicular to the flow. Okay, so this is 90 degree, and this will be forming at a when flow is supersonic. And if you go, so the okay, so fine, yeah. Then third chapter is your oblique shock wave. This is nothing but your normal shock wave was perpendicular, but in this case, oblique shock wave will be inclined at some angle. Okay, so this is your shock angle. So okay, so this important topic, you need not to worry about this. I'll be beautifully explaining all these topics so that you will understand this, and at the end you will be solving many questions. Then all these topics are okay. Detached shock wave is again one kind of interesting phenomena when you have a this kind of blunt body. You will find generally in the space vehicle which are re-entering to the Earth atmosphere, when your incoming Mach number or this vehicle velocity is very high, about 20 or 25 Mach number. So this kind of shockwave formation will be happening. Okay, detached shockwave, we'll call it as a bow shockwave. This is detached from this body surface. Okay, so to be very precise, yeah. Okay. So this will be detached. We have a chapter 4 as a Rayleigh flow. Rayleigh flow is nothing but your when you add heat to the flow, what happens at the exit of this? This is nothing but we'll be covering in the Rayleigh flow. Then we have a Fano flow. Fano flow is saying that when you consider friction to it to the flow, when you consider friction to the flow, what happens to the flow properties at the exit? That's what we'll be dealing with in Fano flow. Then we have some miscellaneous topic, your Rayleigh supersonic pitot formula, then pitot tube in incompressible and compressible flow, then supersonic wind tunnel, and also we'll be seeing subsonic wind tunnel, then shock reflection interaction and flow visualization technique. Because one question they asked in 2021, so we can't skip this topic. We must consider. Okay, so I think I have discussed the what are the important topic we'll be covering. So if you see broadly, so broadly gas dynamics deals with. So please guys focus on this because this will give the idea that why we need to study the gas dynamics and why it is in our GATE aerospace syllabus. So gas dynamics is what, guys? So gas dynamics, when your flow speed is very high in the sense that your kinetic energy is very high. When you go in incompressible flow, this doesn't make sense in a high speed flow because the kinetic energy is not that good or that high. So our gas dynamics starts from when Mach number is greater than 0.33. Okay, in a flow field. So when you have a when you have a compressible flow, because Mach when greater than 0.33, we call it as a compressible flow. Okay, so when you have a compressible flow in a flow field, so the flow feature will be happening. It will be having because okay, so as of now, let's consider. Okay, so anyway, when your Mach number is greater than 0.33, what is happening in the flow picture? What is happening in a, let's say, duct, or let's say the diverging duct? What is happening in a converging duct? Or let's say your Mach number 4 is encountering Mach number 0.4 is encountering with some angled plate or wedge angle. So what is happening to this case? So we will be discussing all these things. Or when this kind of airfoil you are having, what is happening when Mach number is 0.5, let's say. So this thing, so compressible flow or gas dynamics deals with this all important thing. When let's say Mach number is greater than 1, so somehow you're having some obstacle kind of thing, this kind of thing, this is obstacle. Okay, so in this case, when flow is approaching to the obstacle, there will be formation of normal shock wave. So what will happen across the normal shock wave to the pressure or to the temperature or to the velocity or to the Mach number or density? So what will happen across the normal shock wave? What if let's say you have some wedge kind of thing and some supersonic flow is approaching to this? So what will happen to this in this case? So this case, there will formation of oblique shock wave. So across again oblique shock wave, what is the flow feature? Again, Mach number, your pressure, your temperature, your density, your T naught, your P naught. Again, these quantities will be dealing with your stagnation, temperature, and pressure. And okay, and again, let's say you have a considered arc and flow is happening with a let's say subsonic or supersonic. Because anyway, we were discussing. Let's say flow is happening at a supersonic speed. So if you add heat to this flow, what will happening to these exit? Again, similarly, you have fan of flow. So if you consider friction to it, what will happen to the flow at the exit of duct? That's what we have to discuss. And at the end, some flow feature again, some let's say you have a two wedge angle. Okay, and there is one more wedge angle, and supersonic flow is happening time greater than one. Similarly, in this case, time greater than one. What will happen? Let's say this kind of shock formation happens, and here shock interaction is happening from different family. So what will happen in this case? We'll be discussing. So again, this is an interesting phenomenon. And let's say this kind of flow you are having, there's a ramp and this is a concentrated down. So again, there will be shock wave formation. Your magnetic will be supersonic. There is shock wave formation. This shock wave will reflect from this. This is the physical boundary or wall. Okay, this shock wave will reflect like this. So again, this is station number 1, this is station number 2, this is station number 3. So our motto is what will happen or what is Mach number, pressure, and flow properties or flow feature at this station number 3. That's what we need to predict. So if I give you the more application point of view, if you have seen your I think some supersonic aircraft, if you see, fighter jet, you will see at the front you will see this kind of uh, nose you will see. Okay, so and let's say this is diffuser, supersonic intake. Okay, this is supersonic intake. Generally, this kind of intakes are designed. Okay, okay. So let's say these are a supersonic intake, and your aircraft is flying with a very high speed Mach number. Let's say two. Now, what will happen in this case? There will be formation of shock wave. Again, there will be formation of shock wave, oblique shock wave. Similarly, this pattern will goes along. Okay, so this kind of flow feature you will observe, and in your actual aircraft, this will flow will go like this, and at the end it will compressed. Your pressure will increase to the very high value. That's what we want, because if we want very high pressure, so that we can do a good combustion. Right? So, okay, I hope it is clear. And if you see some CD nozzle, okay, CD nozzle is, we need to study this again. CD nozzle says that these are the nozzle used in your rocket, right? Rockets. So this is what nozzle is used in your rocket, so that you can have a very high exit Mach number, so that you can propel in a very high speed, okay, in forward speed. So where there will be again beautiful flow feature will be establishing that there will be formation of. You might have seen some videos, right, on internet. There will be this kind of, okay, physical boundary pressure line. You might have seen this kind of beautiful diamond shape or diamond shape pattern. There will be again steady nozzle. Okay, let's wait for this. Okay, yes. So there will be again uh, when this phenomena happens, when you have pressure difference across the atmosphere. This is atmosphere, and this is your exit nozzle exit. So this kind of flow feature you will be observing. These are the oblique shock wave. These are the expansion fan. So these are the important phenomena will be happening in your actual real life. So I hope I try to motivate you, so you got some motivation for this subject, gas dynamics. So again, I'll emphasize that uh, uh, please go through this syllabus kind of thing. What are the important thing we need to cover, and you can make according to your timetable. And next lecture, I'll be straight away starting with the isentropic flow. That is your first chapter. Okay, again, I'll be saying that this subject you can't skip, because this is having heavy weightage. Oh, this having a heavy weightage of 7 to 9 marks. So I'll try to make sure that you get 7 or 9 to 9 out of it. Okay, and at the end you will be playing with the equations and questions of your gate exam. Okay, I hope this is clear and understood. And if you having any doubt or question or want to say something, you can ask me, or you can post a comment in a comment section. Okay, fine. Okay, let's meet in the next section, guys. Bye bye.